Right, so we're going to finish up going through our interpretation step, and we're going to use kind of that information that was printed up above at the top of the page. So a student claimed that spinning a coin rather than flipping a coin leads to a biased outcome. If we spin the coin 20 times and see 7 heads, which gives us a sample proportion of p hat of 0.35%, or excuse me, 0.35 or 35%, assume the required conditions are satisfied so that the sampling distribution of the test statistic is approximately the standard normal distribution. Find the approximate p-value and explain what it means. So in this case, what has been done in this kind of problem that we're going to see here, where we are given information from a technology output and then asked to make an interpretation, is a common type of problem that we're going to see. Right? So if we go through and we think about this, flipping a coin, we know that we have a 50% chance of landing heads. So even though it's not specifically stated in our problem, that means that our P naught is 50% or 0.50, right? Because that's what we're thinking about when we're flipping a coin. All right, so what do we know? Our sample size was 20 coin spins. Our P hat value, 7 out of those 20 spins, or 35% or 0.35, landed in heads. Our null hypothesis, P equals, remember our null and alternative hypothesis always go back to our P naught. So P equals 0.50. Our alternative hypothesis, right, is going to be P not equal to 0.50, right? Because the student claimed that spinning a coin leads to a biased outcome. A biased outcome means it's not equal to 50% or 0.50. Right, so technology was used, and instead of going through and us finding our standard error and our z-value and our p-value, technology was used and we're given a bunch of information here. Right. So our p-value that we see here is about 18%. So we're going to look a little bit more about that p-value, and then we're going to draw and interpret a conclusion. All right, so let's start with our p-value. So up here, and just for lack of extra space down at the bottom, we're going to say the p-value is about 0.18. That tells us that if spinning the coin is fair, then the probability of seeing an outcome as extreme or more extreme than our value of 7 out of 20 or 0.35. 0.35 heads is about 18%. Okay, so our p-value tells us about the probability of seeing an outcome as extreme or more extreme than what was observed. Right, so our probability of seeing an outcome as extreme or more extreme than our 35% or 0.35 is about 18%. Right, now we need to draw and interpret a conclusion. Right, so what we're going to do here is we are going to compare our p-value to alpha. So if we look at this, and kind of a different way that we can write this out, is we're going to compare our p-value to alpha. So our p-value is 0.18 and alpha is 0.05. Right? So I don't know that we're necessarily told this, but if we're not told our alpha, then we're always going to assume it's 5%. So if we compare these two values, we have a p-value of about 18% compared to an alpha of 5%. This means that our p-value is greater than alpha, right? 18% is greater than 5%. So since this is the case, this tells us that we will not reject. Okay, so going up to our little thing up here, if our p-value is greater than alpha, we are not going to reject our null hypothesis. So not reject our null hypothesis. So in our problem, that means that we're not going to reject our null hypothesis. So we are going to assume that it holds. And that means that our if our null hypothesis holds, that means that our alternative hypothesis is not the case. So since we did not reject our null hypothesis, we do not reject the null hypothesis that spinning the coin is fair. Right. So as we go through and we're working through these problems, oops, I just cut that part off at the bottom entirely. Since our p-value was greater than alpha, our p-value is 18%, which is much larger than 5%, we did not reject our null hypothesis. And since we did not reject our null hypothesis, we assume that spinning the coin is, in this case, fair.